This is 3-5, slopes of lines. Try to complete the warm-up and hit play when you're ready to see all of the answers. Remember, when 0 is on the bottom, the answer is undefined. We did this with skiing last year, if you had me. And if 0 is on top, the answer is 0. So we can use the slope formula to calculate slope, which is right here for us. M is equal to, M stands for slope, y2 minus y1 over x2 minus x1. And it's also rise over run, so we can count up and over. So you could make like a right triangle and you can count how many spaces up. 1, 2, 3, 4, 5, 6. And over. 1, 2, 3, 4. Since we went over to the right, it's 4. Positive 4. So 6 over 4, which is 3 over 2, is the slope. Okay, so for example 1, it says line AB. So let's take a look at line AB is right here. It says to use slope formula. We would need the coordinates of A and B to do that. So let's get the coordinates for this. So we do M equals, I wrote my coordinates over to the side for A and B, but M equals y2 minus y1, so that'd be 7 minus 7 all over x2, which is 3, minus x1 is negative 2. And so 3 minus negative 2 becomes a plus. 7 minus 7 is 0 over 5. Since the 0 is in the numerator up top, the answer is 0. And this makes sense because if you look at the line, that's a 0 slope line. I said if I were skiing and I was standing on that line, I'd be going 0 miles an hour. If you had me last year, that would make sense. Okay, line AC now. Well, line AC is this slanted line right here. Let's get the coordinates. A is going to be at negative 2, 7, and C is at 4 on the x and 2 on the y. So C is at 4, 2. And so we'll do M equals, well, y2 is 2 minus y1 is 7 all over x2, which is 4, minus x1 is negative 2. And that minus a negative becomes a plus, so 2 minus 7 is negative 5 over 4 plus 2 is 6. And we can check this one. If we just count rise over run, so rising down 1, 2, 3, 4, 5. So down 5, negative 5. To the right, 1, 2, 3, 4, 5, 6. To the right is positive 6. So M equals negative 5 over 6 is correct. Let's look at line AD. Well, line AD is an undefined line. So this should come out as undefined. But we need to use the slope formula it said. So I'm going to find my coordinate for D. D is at negative 2 on the x, positive 1 on the y. And so I'm going to do M equals y2, which is 1, minus A's y1, which is 7. So 1 minus 7 over x2 is negative 2 minus negative 2, which becomes a plus. 1 minus 7 is negative 6 over negative 2 plus 2 is 0. Since 0 is in the denominator, that's no good. We have our sad face there. Negative 6 divided by 0 is undefined. If you do that in your calculator, it actually comes up as error or syntax error, because we can't divide by 0. Okay, line CD now. Line CD is this slanted line right here. And so I have my coordinates already for C and D. They're on the right here. And so I'm going to do M equals y2, 1 minus 2 over x2 minus x1, negative 2 minus 4. 1 minus 2 is negative 1. Negative 2 minus 4 is negative 6. And we have two negatives here. A negative 1 divided by negative 6 is 2 negatives divided become positive. So positive 1/6. So M equals 1/6. And we can check this with rise over run. So if I look at my right triangle here, I'd be going up 1 and then to the right 1, 2, 3, 4, 5, 6. So up 1 over to the right 6 would be 1/6. So that's correct. So you can check your slope by using rise over run, or you can do rise over run and then check by using slope formula. Here's our different types of slopes. I've kind of been talking about it along the way. We have our positive slope that goes up. If you're skiing, you'd be going uphill. If you're skiing, you come along from left to right, you're skiing, you go downhill, that's a negative slope. If you're not moving because it's a flat surface like this, that's a zero slope. And if you skied on this, we all know that would not end too well, that's an undefined slope. Okay, one interpretation of slope is rate of change. The rate of change is the change in y over the change in x. Okay, Justin is driving home from his college dormitory. At 4 o'clock, he is 260 miles from home. At 7 o'clock, he is 455 miles from home. Graph the line that represents Justin's distance from home at a given time. So, since the miles from home he is depends on what time it is, the miles are the dependent variable, so I put them on the y-axis, and the time is the independent, I put that on the x-axis. And now I'm going to graph that. So at 4 o'clock, he's 260 miles from home, approximately here. And at 7 o'clock, he's 455 miles from home, which is approximately here. And so we want to find the slope of that line, which is the change in y over the change in x. So I wrote the change in y values up top over the change in x values in the denominator down below. Then I simplify this and I get 65, and so now we need to interpret that. Well, what does that mean exactly? Since up top in the numerator we had miles, and down below we have number of hours, what this represents is that for every 1 hour we've gone 65 miles. I can actually just take the wording from the x and y axis, so it's 65 miles, x, change in y, so miles, over change in x, which is hours, 65 miles per hour. To determine whether lines are parallel, perpendicular, or neither, we need to remember from last year that the parallel lines theorem states that they have the same slope. Parallel lines have the same slope. The perpendicular lines theorem states that the product of the slopes is -1. We talked about this last year, but we can also say then that they are negative reciprocals. The slopes are negative reciprocals of each other. So what does that mean? Well, if one slope is 1/2 and the other is the opposite sign, which would be negative, the perpendicular slope would be negative, and then flip 1/2 over, which is 2/1 or 2. If the slope of one line is 1/3, then the negative reciprocal would be opposite sign and flip the 1/3 to 3/1. If the slope is 4, then the perpendicular slope would be change the sign to a negative and flip 4/1 to 1/4. Okay, so for example A, we can graph these and we can use slope formula. We could do rise over run and slope formula to check the slope. Okay, I used slope formula for each of these, and I got 3 and -1/3. Since those are negative reciprocals of each other, these lines should be perpendicular. Let's make sure it looks that way on the graph, and it does. They look like they intersect and form a right angle. That's perpendicular. Okay, let's find the slope of each of these. Okay, for line GH, I found the slope to be 1, and I can check this with rising down 1, 2, 3, 4, and to the left 1, 2, 3, 4. So -4 over -4 is +1. So I know that slope's correct. So my slopes ended up not being the same slope or negative reciprocals. So it's not parallel or perpendicular. It almost looks perpendicular in my drawing, but it's not. Okay, I found the slope of CD to be 2, and I just checked with rise over run. I got -4 over -2. Well, 2 negatives make a positive, and 4 divided by 2 is 2. So that's correct. Let's check EF. Okay, for EF, I also got a slope of 2. Let me graph that. So So when I graph EF, it is actually evident that since they're the same slope, these two lines are parallel.